Northern California is no stranger to diverse weather. From the sun-drenched beaches to the foggy, cool mornings in San Francisco, the region experiences a wide range of climatic conditions. However, the upcoming weather forecast is something quite out of the ordinary. An impending polar vortex event threatens to bring an unusual chill to the Golden State. This isn't just a typical cold front, it's a significant meteorological event that could reshape the winter landscape of Northern California. This winter phenomenon, originating in the Arctic, is forecast to bring frigid temperatures and the potential for significant snowfall. The polar vortex, a large area of low pressure and cold air surrounding the Earth's poles, occasionally breaks down and sends cold air southward. This time it's Northern California's turn to feel the Arctic's icy breath. Residents are advised to prepare for a taste of true winter weather. This means stocking up on essentials, ensuring homes are well insulated, and making sure vehicles are equipped for icy roads. For many, this will be a new experience, as such extreme cold is rare in this part of the state. This event is a stark reminder of the interconnectedness of global weather patterns. What happens in the Arctic doesn't stay in the Arctic. The shifting polar vortex can have ripple effects, influencing weather far beyond its usual confines. The polar vortex, a swirling mass of cold air typically confined to the Arctic, is projected to weaken and expand southward. This weakening allows the cold air to spill out, traveling down through Canada and into the United States, reaching as far as Northern California. This shift will bring Arctic air far south of its usual boundaries, impacting weather across North America and beyond. The effects will be felt not just in terms of temperature, but also in the form of increased snowfall and potentially hazardous conditions. The potential for significant snowfall and icy conditions raises concerns for infrastructure and daily life. Roads may become treacherous, power lines could be weighed down by ice, and everyday activities might be disrupted. Northern California, accustomed to milder winters, may face disruptions to transportation, power, and other essential services. Snowplows and salt trucks, more common in the northern states, might become a rare but necessary sight in the region. Understanding the science behind this weather event is crucial for preparedness and adaptation. Meteorologists and climate scientists are closely monitoring the situation, providing updates and guidance to help residents navigate this unusual cold spell. By staying informed and taking proactive measures, Northern Californians can better cope with the challenges posed by this polar plunge. The Arctic Oscillation, a climate pattern characterized by pressure fluctuations in the northern hemisphere, plays a key role in this impending weather event. This oscillation is essentially a seesaw of atmospheric pressure between the Arctic and the mid-latitudes. When the pressure is high in the Arctic, it tends to be lower in the mid-latitudes, and vice versa. These fluctuations can significantly impact weather patterns, not just locally but globally. Currently, the Arctic Oscillation is in a negative phase. This means that the pressure is higher than usual over the Arctic and lower over the mid-latitudes. This phase is crucial because it sets the stage for a series of weather events that can have far-reaching consequences. This phase weakens the jet stream, a band of strong winds that typically keeps Arctic air contained. The jet stream acts like a barrier, preventing cold Arctic air from spilling southward. However, when the Arctic Oscillation is in its negative phase, this barrier weakens, allowing the cold air to escape. A weakened jet stream allows the polar vortex to expand southward, bringing frigid air to lower latitudes. The polar vortex is a large area of low pressure and cold air surrounding the Earth's poles. When it expands, it can push cold air much further south than usual, leading to significant drops in temperature. This expansion is what brings the potential for unusually cold temperatures and winter weather to regions like Northern California. Areas that are not typically known for severe winter weather can experience snow, ice, and freezing temperatures, disrupting daily life and causing various challenges. The Arctic Oscillation's influence highlights the interconnectedness of global weather systems. Changes in one part of the world can have a domino effect, influencing weather patterns thousands of miles away. This interconnectedness is a reminder of how dynamic and complex our planet's climate system is. The negative Arctic Oscillation phase can persist for weeks or even months, influencing weather patterns across the northern hemisphere. This prolonged phase can lead to extended periods of cold weather, affecting agriculture, energy consumption, and even human health. Understanding this pattern helps meteorologists anticipate and predict the potential severity and duration of winter weather events. By studying the Arctic Oscillation, scientists can provide more accurate forecasts, helping communities prepare for and mitigate the impacts of extreme weather. This knowledge is crucial for planning and response efforts, ensuring that people and infrastructure are better equipped to handle the challenges posed by severe winter conditions. The heart of this polar vortex event lies in the influx of frigid air masses originating from Alaska and western Canada. These regions, known for their harsh and unforgiving winters, are now sending waves of cold air southward, impacting a vast area. These air masses, carrying temperatures far below freezing, will sweep southward, bringing a dramatic shift in temperatures across much of North America. As they move, they will displace the relatively warmer air, leading to a sudden and noticeable drop in temperatures. This phenomenon is not just a minor cold snap. It is a significant weather event that will affect millions of people. Northern California, typically accustomed to mild winters, will experience a stark contrast as these Arctic air masses arrive. Residents who are used to moderate temperatures will need to brace for an unusual and intense cold spell. The sudden change will be evident as the region transitions from its usual mild winter conditions to a landscape blanketed in snow and ice. Coastal regions, often buffered by the Pacific Ocean's moderating influence, will feel the chill as temperatures plummet. The ocean usually acts as a thermal buffer, keeping coastal areas relatively warm even in winter. However, the sheer intensity of the Arctic air masses will override this effect, leading to colder than normal conditions along the coast. This will be a rare and striking sight for those living in these areas. Mountainous areas can expect significant snowfall as the cold air collides with moisture. The interaction between the frigid air and the moist atmosphere will result in heavy snowfalls, creating picturesque yet challenging conditions. Ski resorts and mountain communities should prepare for an influx of snow, which, while beneficial for winter sports, can also pose risks such as avalanches and difficult travel conditions. The arrival of these Arctic air masses marks a significant departure from normal winter weather patterns in Northern California. Typically, the region experiences mild and wet winters, but this event will bring a level of cold and snow that is rarely seen. This unusual weather pattern will be a topic of discussion and concern for meteorologists and residents alike as they navigate the challenges posed by the extreme conditions. Understanding the origin and path of these air masses is crucial for accurate forecasting and timely preparation. Meteorologists are closely monitoring the situation, using advanced technology and satellite imagery to track the movement of the cold air. Their analyses and predictions are vital for informing the public and helping communities prepare for the impending weather. By staying informed and taking necessary precautions, residents can better cope with the challenges brought by this Arctic air event. Section 4. Snowfall predictions across the continent. As this polar vortex event unfolds, snowfall will be a significant concern across North America. Regions accustomed to heavy snowfall, such as the Rocky Mountains and Great Lakes region, can expect above-average accumulations. However, the unusual southward reach of this polar vortex means that even areas unaccustomed to significant snowfall, including portions of Northern California, could see accumulating snow. This unusual event highlights the far-reaching impacts of a disrupted polar vortex. The potential for heavy snowfall raises concerns for transportation, infrastructure, and public safety. Understanding the expected snowfall amounts helps communities prepare for potential disruptions and ensure the safety of residents. Section 5. Bracing for severe winter weather. Beyond the frigid temperatures and snowfall, this polar vortex event brings the potential for severe winter weather. Extreme cold, with temperatures dipping well below freezing, poses risks to human health and infrastructure. Snowstorms, driven by the collision of cold Arctic air with moisture, could further exacerbate the impacts of this weather event. Heavy snowfall, combined with strong winds, can lead to blizzard conditions, reducing visibility and making travel extremely dangerous. Preparing for the potential for severe winter weather is crucial. This includes ensuring adequate heating, stocking up on essential supplies, and staying informed about weather forecasts and warnings. Section 6. A global chill impacts beyond North America. While North America braces for the brunt of this polar vortex event, its impacts will be felt far beyond the continent. The disrupted jet stream and southward flow of Arctic air can influence weather patterns across the globe. Europe and Asia may experience colder than average temperatures and altered precipitation patterns. These temperature anomalies can disrupt agriculture, transportation, and energy demands. This event underscores the interconnected nature of Earth's climate system. Changes in one region, such as the Arctic, can have cascading effects on weather patterns across the globe.